two objects in this system which are accelerating. There is, first of all, the counterweight, A, and secondly, the lift, L. So we start by drawing a free body diagram, first of all, for the counterweight. Let's ask ourselves what forces are acting on that weight. Well, there's gravity acting downwards, which is 150 times g, because the mass of the counterweight, we're told, is 150 kilograms. And then in the upwards direction, there's the tension in the cable, which we'll call T. Now, considering the lift, again, ask yourself what forces are acting on the lift. There's gravity acting downwards, which is the mass of the lift, 500 kilograms times g. And then upwards, we've got two forces. We've got the tensions in both cables. So the tension in the left-hand cable is just equal to T again. And the right-hand cable, the tension in that is 5 kilonewtons, because we're told in the question that the motor supplies a constant force of 5 kilonewtons on the cable at B. Also shown on the screen at the moment are the acceleration vectors for both the counterweight and the lift. And because the cable between A and L has a fixed length, then AL must be equal to minus AC. The magnitude is the same, so we'll just call that A from now onwards. And we're going to take the upwards direction as positive. Right, having drawn our free body diagrams, the next step is to write down our equations of motion. So considering first of all the counterweight, the resultant force on the counterweight is T minus 150 G. Putting that into Newton's second law equation gives us on the right-hand side the mass times the acceleration. So that is minus 150 A. The minus sign now because it's in the downwards direction. Sorry, the acceleration is in the downwards direction. Transposing that equation gives us an expression for T, and we'll call that our equation 1. We'll now go over to the other side of the screen and consider the lift. The resultant force on the lift is T plus 5 kilonewtons minus the 500 G, and that is equal to the mass times the acceleration, so that's just equal to 500 times A. And that we will call equation 2. If we now substitute equation 1 into equation 2, we get that 150G minus 150A plus 5 times 10 to the power 3 minus 500G is equal to 500A. Transposing that, in a couple of steps, we get the expression for the acceleration, which is 5 times 10 to the 3 minus 350G divided by 650, and that works out as 2.4 meters per second squared. The question asked us to determine the velocity at time t 3 seconds. To do that, we use one of the kinematic equations. Because we know that V0 is 0, and we substitute t equal to 3 seconds into V equals V0 plus AT, that gives us finally 7.2 meters per second.